Hello students, welcome to the part 2 of lesson 8, Earthquakes. In this lecture, I will discuss the measurement of earthquakes, the constructive and destructive effects of earthquakes, the distribution of earthquakes all over the world, and the different ways of predicting earthquakes. We begin with measurement of earthquakes. The seismograph, the Richter scale, and the Mercalli scale are used for measuring the direction, magnitude, and intensity of earthquakes. And we begin with seismograph. The direction of movement of seismic waves and their passage at a particular point is recorded by an instrument called seismograph. It has a pen attached to it. This pen vibrates with the earthquake waves, recording their movement on a traveling strip of paper. It also calculates the difference in the arrival of P and S waves. This interval is then used to calculate the distance between the recording station and the epicenter. Next, we have the Richter scale. The Richter scale measures the magnitude of an earthquake or the amount of energy released during an earthquake. It measures the power of an earthquake on a scale of 1 to 9. Each point upward from 1 represents 10-fold increase in the amplitude of shock waves. Thus, an earthquake wave of magnitude 6 will be 10 times stronger than magnitude 5. So here we have the Richter scale. Suppose there is an earthquake of magnitude 2 on the Richter scale. The energy released will be equal to 600 kilograms of dynamite. If it is magnitude 3 on the Richter scale, the energy released will be equal to 20,000 kilograms of dynamite. If it is magnitude 7 on the Richter scale, energy released is equal to 20 billion kilograms of dynamite. And if it is magnitude 9 on the Richter scale, then the energy released is equal to 20 trillion kilograms of dynamite. Next is the Mercalli scale. The Mercalli scale measures the intensity of an earthquake. This means that it measures the damage from earthquakes and the observed effects on a 12-point scale. So let us understand the Mercalli scale. For example, this is the Mercalli scale given. Intensity 1, not felt except by a very few under especially favorable conditions. Intensity of 2 on the Mercalli scale, felt only by a few persons at rest, especially on upper floors of buildings. Intensity of 5, felt by nearly everyone, many awakened, some dishes, windows broken, unstable objects overturned, pendulum clocks may stop. Intensity 10 on the Mercalli scale, some well-built wooden structures destroyed, most masonry and frame structures destroyed with foundations, rails bent. And intensity of 12 on the Mercalli scale, damage total. Lines of sight and level are distorted, objects thrown into the air. Here are some major earthquakes. This picture shows the Assam earthquake of 1897, which had a magnitude of 8.7 on the Richter scale. And this shows the Gujarat earthquake of 2001, magnitude of 7.7 on the Richter scale. The Nepal earthquake of 2015. It was magnitude of 7.8 on the Richter scale. This earthquake killed over 8,000 people and injured more than 21,000 people. It made many people homeless, with entire villages flattened across many districts of Nepal. It also destroyed centuries-old buildings, including UNESCO World Heritage Sites in the Kathmandu Valley. A World Heritage Site is a natural or man-made site, area, or structure recognized as being of outstanding international importance and therefore as deserving special protection. But as you can see, the earthquake destroyed so many of these important sites. Continued aftershocks occurred throughout Nepal at intervals of 15 to 20 minutes. A major aftershock occurred on May 12, 2015 with a magnitude of 7.3 on the Richter scale. This aftershock killed more than 200 people and injured 2,500 people. Now we start with effects of earthquakes. In geological terminology, earthquakes are a part of endogenic forces and are regarded as constructive movements of the Earth's crust. But from human point of view, earthquakes are regarded as destructive, causing loss to property and life. Some constructive effects of earthquakes are energy release. Earthquakes help the Earth to release its stored up energy. The majority of earthquakes occur around the plate margins. This energy release helps to keep the Earth in good shape. Information about Earth's interior. The seismic waves provide an effective probe of Earth's interior. They constitute the main method of collecting data upon which we base our present concepts of the interior of the Earth. The next constructive effect of earthquakes is formation of landforms. On account of both vertical and lateral displacement of the Earth's crust, earthquakes may raise or lower parts of Earth, especially near the seashore. Sagami Bay of Japan was uplifted 200 meters in 1923. This is a picture of Sagami Bay. Landslides triggered by earthquakes cause formation of lakes, as has happened at many places in the Himalayan region. Now we start with the destructive effects of earthquakes. Collapse of structures and danger to human life. Severe earthquakes cause houses and other structures to collapse. There is great loss of property and human life. Landslides. The shock waves during an earthquake destabilize the loose rocks, which leads to landslides. This damages buildings and transport system. Submergence. The forces of uplift and subsidence also cause submergence of coastal areas. For example, Dwarka in Gujarat, which now lies submerged under the sea. Dwarka was the ancient kingdom of Lord Krishna. Course of rivers. Earthquakes have changed the course of rivers in the past. They have thus rendered many areas unsuitable for irrigation and agriculture. Fires. During an earthquake, fires break out due to inflammable material, broken gas pipes, and bursting of gas cylinders. Besides, damaged oil refineries and live electric wires catch fire and damage life and property. Flash floods. Strong shock waves damage dams and embankments, and the water stored there spreads speedily, causing flash floods. Besides, debris produced during an earthquake blocks the flow of the river. The river flow gets diverted from its original course. This diversion causes flash floods and damage to life and property. Tsunami. A tsunami is a large destructive ocean wave, as you can see here, that can be generated by any disturbance that rapidly displaces a large mass of water, such as an earthquake, volcanic eruption, landslide, or meteorite impact. However, the most common cause is an undersea earthquake. The name tsunami is from the Japanese word su and nami, meaning harbor and wave respectively. So tsunami are harbor waves. They occur most frequently in the Pacific Ocean but are a global phenomenon. For example, the 2004 Indian Ocean earthquake triggered a series of lethal tsunamis on December 26, 2004 that killed approximately 275,000 people, out of which more than 168,000 died in Indonesia alone. The next topic is distribution of earthquakes. There are three main earthquake belts of the world, and the first is the Circum-Pacific Mountain Belt. This is the Circum-Pacific Mountain Belt here, all around the Pacific Ocean, and this is another view of the Circum-Pacific Belt. It is also called the Pacific Ring of Fire, as we have already discussed in the previous lesson. This belt has 70% of all earthquakes. A part of San Andreas Fault, here is the San Andreas Fault, lies in this belt. This fault zone makes California in USA highly prone to earthquakes. The area of Japan, Philippines, and Indonesia all form parts of this belt and are prone to severe earthquakes. The second belt is the Mid-World Mountain Belt. It stretches from Eastern Europe, covering the alpine Himalayan ranges in Europe and Asia. About 20% of all earthquakes occur in this zone. So this is the Mid-World Mountain Belt. The last earthquake belt is the Mid-Atlantic Ridge. The Mid-Atlantic Ridge comprises of areas along the mid-oceanic ridges as well as many islands near the ridges of the Atlantic Ocean. So this is the Mid-Atlantic Ridge. The remaining 10% of earthquakes occur in this belt. In this ridge, two tectonic plates move in opposite direction. So plates are moving in opposite directions like this because they're diverging away from each other. Some moderate earthquakes are recorded along the ridge. The Rift Valley of East Africa is considered an extension of this belt. So as you can see, the Mid-Atlantic Ridge is also passing through Iceland. And you can see a picture of this Mid-Atlantic Ridge over here. Thousands of tourists go to this place every year and see the Mid-Atlantic Ridge on land. Here also you can see this is the map of Iceland, and you have the Mid-Atlantic Ridge passing like this, and you have the Eurasian plate and the North American plate diverging away from each other. Our last topic is predicting earthquakes. Earthquake prediction in the past was left to astrologers and mystics. Today, it is a respectable scientific pursuit. The Russians were the first to discover P and S seismic waves in 1960s, on the basis of which predictions were made. These waves are still the only means available to seismologists to predict earthquakes. The theory of plate tectonics offers another means of prediction on scientific lines. Japanese use the methods of measuring changes in sea level and variations in Earth's magnetic field to predict earthquakes. However, no method is still foolproof, as has been proved by recent earthquakes in Japan, India, and the USA. I conclude this lesson here. In today's lecture, I explained the measurement of earthquakes, the constructive and destructive effects of earthquakes, the distribution of earthquakes, and predicting earthquakes. Thank you and have a nice day.